All right, so these are video solutions to logic worksheet, which is tricky. So you have a positive 8 microcoulomb charge and a minus 15 microcoulomb charge, and they are glued down. Okay, they're just stuck. So this is like the Van de Graaff being negative and the baby Van de Graaff being positive. Calculate the position at which you would place a minus 4 microcoulomb charge so that the net force on the minus 4 microcoulomb charge is 0. So these guys are glued down. This is like the graphite ball, and you want to figure out where you're going to put that. Okay, so the first thing you want to remember is in order for the forces to balance, you need to be closer to the weaker charge. And ignore positive and negative here. 8 is less than 15. So don't say 15 is weaker because it's minus 15. Just look at magnitude. 8 as a number is smaller than 15. So that you know you're going to be somewhere on either side of the 8. Okay. And if they were the same sign, if the 8 and the 5 were both negative or both positive, you would put the minus 4 between them. But because they're opposite sign, you want to put the minus 4 outside. And if that's not obvious why, just do trial and error. So let's put the minus 4 here. And the minus 4 likes the 8. And it is repelled by the 15. And there's some point in here that those two forces will balance. If I go too close to the 8, then that turquoise force is going to get bigger. If I move too far away, then it's going to get smaller. Okay. So somewhere in here is where we're going to put it. Let's say that you weren't sure. Let's say that you were going to put it here. You can always check your work. Then the minus 4 does not like the 15, so it feels a force of repulsion from the 15, and it likes the 8. Okay, so do trial and error if you need to, that there's no way that the charges can cancel in between these two because they're both of the 4 charges are pushing the minus 4 to the left. So in order to cancel, you need 1 to the left and 1 to the right. So you know that's not going to work. Okay, so that's step 1 is figuring out where it is. And then we're solving for x. We're solving for how far away from the 8 it needs to be. So what do we want to happen? We want the force from the 15 to equal the force from the 8. And the formula is K, the charge you care about, which is the 4. The other charge it's interacting with, which is one of them is the 8. The distance between the 4 and the 8 is this unknown distance, x. And we want that to equal, oops, I started talking about the 8. We want that to equal the force from the 15. So that's K, the charge you care about, the 15 microcoulomb charge. How far away are these two? 0.25 plus x squared. Okay, hopefully all that makes sense. The charge you care about is the same. It's attracted to the 8 and it's repelled by the 18, and we want those two to cancel, the forces to cancel. But the reason I pause on cancel is be nice to yourself. There's a K on both sides, so that doesn't matter. I'm going to plug in this number just so you remember. I would suggest that Q1 is always the charge you care about. The charge you care about is the 4 microcoulomb charge. Ignore the minus sign. You use your force diagram to decide on the signs. And the charge you care about is always part of your calculation. This one is how much it is, what is it, attracting or hating the 15, being repelled. This is tricky. The denominator is a little bit complicated. All right, but then you say, oh, look, these are the same. Let's make our lives easier and get rid of those. And then I've got a 10 to the 6th that's the same on both sides so that I can cancel that. So what looks really, really complicated turns into 8 over x squared equals 15 over 0.25 plus x quantity squared. And we're solving for x. Okay. So in order to solve for x, we are going to cross multiply. And you get 15x squared equals 8 times 0.25 plus x squared. Now you could multiply this out, a squared plus b squared plus 2ab, but we are going to, it's not wrong, but I'm going to take the square root of both sides to make our lives a tiny bit easier. You got to take the square root of everything. So what we have here is the square root of 15 times the square root of x squared is x equals the square root of 8 times 0.25 plus x. And then, sorry, I'm looking for my key. That turns into 3.87x equals square root of 8 is 2.83 times 0.25 plus x. And then we're going to multiply that 2.83 through, and you get 3.87x equals 0.7075 plus 2.83x. And then we are going to combine like terms. So excuse this other problem. I'll erase this in a second. So 3.87x minus 2.83 from both sides gives you 1.04x equals 0.7075, almost done. And then divide both sides by 1.04, 1.04, and you get an x of 0.680 meters. Whew. Okay, so let's just go back and check. What the heck does that mean? That means if I put this charge 0.680 meters away from the positive 8, it will like the 8 exactly as much as it hates the 15. All right, so that is the answer to question 1. All right, now we have question 2. So we have a 13 microcoulomb and a positive 10 microcoulomb, and they're a certain distance apart. They are glued down. They're not going anywhere. Now we're going to put a -4 microcoulomb charge somewhere so that it is pushed or pulled equally by both. All right, so remember the first thing you want to do is say, in order for the forces to balance, I must be closer to the weaker charge. So that's the 10, because 10 is less than 13. So that means either between the two here or on this side of the 10. If the charges are the same, you want to put it between them. So we're going to put the -4 some distance x away from the 10 microcoulomb charge. So let's double check our work. The -4 likes the 13, and it likes the 10. So if I put it in exactly the right spot, it'll be pulled to the 13 as much as it is pulled to the 10. Okay, and then just quickly, because we did this before, if you put it closer to the 10 on this side, then you would find that that's not going to work because the -4 likes the 10 and it likes the 13. And there's no way these two things will cancel because they're both pointing in the same direction. Okay, so that just confirms this is where we want to put it, and then you're just going to make up some distance, x. I'm going to solve for x, how far away it is from the 10. Okay, and then the net force is 0. So what that means is the force from the 13 is equal in magnitude to the force from the 10, because we already figured out where it needed to be, right? Like in order for the pushes and pulls to be working against each other instead of with each other. Okay, and then formula for the force is K, charge you care about, the other charge, which is 13, over how far apart they are. Oops, I'm going to call this R, distance. I'm going to call this distance to not confuse with X. Needs to equal the force from the 10, which is K, the charge you care about, the 10 microcoulomb over how far apart they are. And then K's cancel. Let's put in this Q1 is going to cancel again, but I'm trying to, so you can do that yourself, but I'm trying to also reinforce that that's always the charge you care about. And then let's go back up. How far apart in the 4 and the 13? This is tricky. The 13 and the 10 are 0.06 meters apart. I'm putting the minus 4x away from the 10, so what's left over is 0.06 minus x. So so in the one we did above, I erased it, but that was 0.06. I can't remember if it was plus or minus. I was plus because it was on the outside. So how far apart are these? These are 0.06 minus x apart, and we need to square that because that's in the formula. And that's going to equal the charge you care about, the 10 microcoulomb charge, over x squared, because these are x away from each other. Okay. What can we cancel? Make our lives easier. That is the same on both sides. 10 to the minus 6 is the same on both sides. So then we're going to cross multiply. So we get 13x squared equals 10 times 0.06 minus x squared. All right, so again, we could do a squared plus b squared minus 2ab, or we could be lazy, clever, and attractive, take the square root of both sides. So this turns into the square root of 13 times a single x equals, that looks like a 0. It's not. The square root of 10 times 0.06 minus x. Okay, and then what do we got? The square root of 13 is 3.61x equals, it's kind of tricky. This is 3.61, right? Because 4 squared is 16 and 3 squared is 9. This is 3.16, so it's a little confusing because I got the same numbers. 0.06 minus x. We're going to distribute that. So 3.16 times 0.06 is 0.1896 minus 3.16x. Then we are going to add this to both sides. So you get 6.77x equals 0.1896. We care about x, so we're going to divide both sides by 6.77. So x is 0.028 meters. Let's go back up and see if that makes sense. The whole distance between the 13 and the 10 was 0.06, so this better be less than 0.06, right? Or the number doesn't make any sense. So that distance is 0.028 meters. If you had decided to label this as x, you would have gone whatever 0.06 minus 0.028. You would have found 0.032, and that's legit too. As long as you show your work, I'm solving for this x or I'm solving for that x. they're both right. All right, those were the math. Solve for X. I'm going to stop there and we'll do a separate video for the logic questions. Okay, hope that makes sense. Thank you for listening.